In the second phase of our violations of the classical least square assumptions, we are going to consider the test for the presence of serial correlation, heteroscedasticity, and autocorrelation. So basically, we estimated the impact of budget deficit on economic growth in Nigeria using the budget deficit variable, which is the difference between expenditure and revenue of the government, and external debt. We added interest rates in the model. This OLS assumption was estimated on the assumption that the series under considerations were merely reverting, or that they became stationary at level. It is on that premise that I estimated this particular OLX model this morning. To check for the presence of serial correlation, you go to View, you maneuver to Residual Diagnostics, you now move on to Serial Correlation LM Test. If you hit this button, you will now be exposed to the lab specification. You click OK without changing anything. You will now be exposed to the serial correlation results. This serial correlation result was estimated with Bush-Godfrey serial correlation LM test, and the first phase of this result, this is the one that we are interested in. If you look at this result, we have the F statistics and we have the observed R square. We have their coefficients and their chi-square distribution. Then we also have the p-value. These p-values are being used to explain or to interpret the results. For you to infer causation in this particular equation estimate, you will now read it by looking at the level of significance of this particular statistics. Whenever time the p-values of either the F statistic or the observed R square is more than 5%, we conclude that there is an evidence of serial correlation in the model or the residual. Recall that the evidence of serial correlation invalidates the assumption of serial independence of the error term we made mention last week. So I'm not happy with this result, and these results do not give me what I wanted. So given that, I will now proceed to actually look at the presence of heteroscedasticity again. So to achieve that, you go to View, you maneuver to Residual Diagnostics again, you move on to heteroscedasticity text. Then you click OK without changing anything in this box. You click OK. If you click OK, you will now be exposed to the heteroscedasticity results projected by Bush, Pagan, and Godfrey. This result is somehow broader than the serial correlation text because it also includes scale explained Essex. Like I said previously, if you look at the probability values of this result and you now compare it with 5% level of significance, you will now observe that these particular p-values are all greater than 0.05. And given the fact that these p-values are greater than 0.05, we will now conclude that there is no evidence of heteroscedasticity in the estimated results, which implies that the assumption of homoscedasticity of the error term is being upheld in this particular estimation. I'm happy with this, and this particular result is desirable in this particular time. So the last one we are going to be doing this morning is to look at the presence of autocorrelation. Recall that when we did the OLX estimation, I gave you previously, I told you that there is an evidence of first order autocorrelation given the behavior of the double Watson statistics. So I told you that the double Watson statistics ranges from 1.50 to 2.50, and any value lower than or higher than this particular range invalidates the double Watson statistics or shows the presence of autocorrelation. To achieve that, or to actually check the validity of such claim, we are going to move on to autocorrelation estimation. So you go to view, you maneuver to residual diagnostic, you move to Correllogram square residual. If you move to the Correllogram square residual, you click OK. Once you click OK, you are going to be exposed to a particular chart that looks like this. This chart was estimated this morning, and if you look at it, we use 41 years observation. The first set, we have the autocorrelation, we have the partial autocorrelation, we have the AC values, also have the partial autocorrelation value, we have the junk box value, which we call the Q statistics, and we have their probability values. If you look at this particular area, we have the spikes, and dotted lines. Whenever time these spikes actually get to this dotted line, is an evidence of autocorrelation, and whenever time these particular spikes are very, very thin, we say there is a damn sideway. Then if there is a damn sideway, it means that this particular spike are not reaching this line, which is also desirable. But whenever time these particular spikes are touching this particular dotted lines, it shows evidence of autocorrelation in the residual. Secondly, if you want to use the autocorrelation value to look at it, if you go through this autocorrelation value, it doesn't move towards a particular direction. And if you look at the probability values of this particular autocorrelation estimate, you observe that majority of them are statistically insignificant, or they are not significant. So given the fact that these particular values are not significant, we now conclude that there is no evidence of autocorrelation in the residual, and basically we are somehow happier now. So in the estimated result, we had initially believed that there is an issue with this, but given the fact that we did an autocorrelation test now, which invalidates that. So basically this is how you look at for the presence of serial correlation and autocorrelation, as well as heteroscedasticity in your estimated results, and you offer interpretation in line with ceteris paribus assumption. Thank you. Stay tuned to our channel as we bring to you how to resolve the problems of serial correlation, heteroscedasticity, and autocorrelation in subsequent videos. Thank you, and God bless you.